but 99% of people misunderstand the Stegosaurus plates. This herbivore remains one of paleontology's greatest puzzles. Its iconic dorsal plates were unlike any other dinosaur feature. These large, bony structures were embedded in the skin. But what was their true purpose? The theories are many. And now that we understand the structure, let's explore function. The most compelling theory involves thermoregulation. Fossil evidence suggests rich blood vessel networks existed. But facing the sun, the plates absorbed heat quickly. Conversely, facing the wind released excess warmth efficiently. But this massive surface area was ideal for temperature control. However, temperature alone doesn't explain their striking shape. Display, particularly during mating or territorial disputes, is vital. Imagine these plates covered in bright, contrasting colors. And a herd would have presented an astonishing visual spectacle. Notice the size variation. Plates near the hips are often larger. But now that we understand the plates, let's examine the spikes. The tail carried 4 formidable spikes, known as the thagomizer. These were not passive decorations, they were active weaponry. The bony structure suggests significant musculature for powerful swings. But crucially, the tail pivots, allowing horizontal striking arcs. Fossil evidence sometimes reveals injuries consistent with defense. These defensive measures suggest powerful predators shared its environment. The low center of gravity made the Stegosaurus stable during defense. Its environment dictated many aspects of its anatomy. It was primarily a low browser, feeding on ground vegetation. Its beak-like mouth was perfectly adapted for shearing tough plants. A small brain suggested instinct-dominated complex decision-making. This simplicity reinforces the idea that defense was crucial. But the sheer complexity suggests multiple roles concurrently. But consider the energy cost of maintaining such large structures. They required substantial nutrients and growth periods. And the discovery record itself offers clues to their arrangement. But early finds showed plates randomly scattered, causing initial confusion. Later discoveries confirmed their paired, alternating configuration along the spine. The placement affects how effectively they could regulate heat. And now, let's re-examine the defensive configuration of the thagomizer. The length varied, sometimes exceeding 1 meter in mature specimens. The key was the flexibility in the caudal vertebrae attachments. A predator would have to target the flanks or head carefully. The skin itself must have been thick to support this armor. The Stegosaurus needed constant energy for maintenance and movement. Its slow digestion required significant internal volume for processing. If thermoregulation was primary, why the odd shapes? But different species show variations, indicating local adaptation. But evolution favors features that maximize survival advantage. During extreme heat waves, passive cooling becomes life-saving. The plates create a massive heat sink along its entire dorsal line. The tail spikes, however, have a clearer, singular defensive role. Imagine the sheer kinetic energy delivered with each powerful lash. It was not built for speed, but for stalwart resistance. Its eyes, small and forward-facing, suggest awareness, not aggression. We see a clear division, passive physiology versus active defense. But this dual utility made the Stegosaurus uniquely successful then. For its life was a careful balance of grazing and vigilance. The skin was likely tough, capable of enduring minor scrapes. The large structures also provided substantial intimidation factor. The plates and spikes together define this magnificent Jurassic survivor. But the mystery persists, but the evidence points toward complex integration. For the Stegosaurus remains a testament to nature's inventive engineering.